Today we learn about the three major ways Spark stores and process data. One is RDD, Dataframe, and Dataset. So think of them like three generations of smartphone. Each newer one brings improvements, but the older one still works. So these are not three separate tools, they are the three levels of abstraction. So RDD is nothing but the lowest level with full control but more work to be done, whereas data frame is nothing but structured and optimized, which is most popular, and data set is nothing but is the mixture of data frame plus type safety, that is nothing but scala and Java. These are only supported for dataset. Okay, this is about the overview of RDDs. So why we need? So a single computer is like one clerk in the office. So big companies have lakhs of records. One clerk can't manage that. So we use many computers together called a cluster. Okay, so a Spark helps manages these computers. So Spark exists because of big data problems such as too large for one machine, too slow for one machine, needs parallel processing. So we need reliability even if one node fails. One worker if is not attending the college, we require the work to be done. So Spark is nothing but a brain that coordinates all computers. So imagine one teacher correcting 10,000 exam papers alone. So they will take weeks. So but what if 20 teachers share that bundle, the same bundle? What if 20 teachers share? Work finishes in a day. So Spark is nothing but principal assigning papers to teachers. Okay, papers to teachers. So that is the Spark thing. That is what Spark do. So what does Apache Spark do? So Spark breaks big work into small pieces. So sends it to computers, runs it in parallel, and then combines the results. That is what the mechanism of Spark. Okay. And if any computer fails, so the Spark recovers, so work doesn't stop. Even if any computer fails due to some error, so it can also recover at that particular data such that the work won't stop in other machines. Okay, one if one fails, work won't stop. So Spark handles task splitting, scheduling, parallel execution, and also with fault recovery, and also result collection. So you need manually assign work that Spark does. So teacher gives a cleaning duty. For example, group A I give for left side. For group B I give for right side. For group C I give benches. So all groups work at the same time. That we call it as parallel processing. What is that? Parallel processing. Okay. So that is what Spark do. Now, how does Spark stores the data? So Sparks need a way to handle data in memory. So RDD came first. That is what initially started with. So the data frame added structure, whereas dataset added type safety. RDD is the basic distributed data, and later data frame was introduced, and later dataset was introduced. So Spark didn't replace RDD. Still, it built better tools on top of it. Initially, it was the thing. Initially, RDD was the thing we'll be using. So RDD is flexible but manual, which means we need to enter everything. Whereas data frame is structured, that is nothing but all rows and columns are being structured and optimized. Whereas dataset is nothing but structured, as well as it use some types of languages such as Scala and Java. Only two languages are supported in dataset, whereas in data frame Python will be supported. Okay. Now what is RDD? So RDD means resilient distributed dataset. So it is the most unique, most basic unit of data in Spark. So it is like a big bag of data spread across many computers, and Spark keeps tracking of those data set, everything, okay, everywhere, every time. So what else do RDD is nothing but it breaks them. So data set is nothing but collection of data, and that collection of data is distributed across machines. And resilience, that is resilient, is nothing but we can recover if anything goes wrong. If any computer fails or if any computer crashes, we will be having replicas, that we call it as resilient. So RDD is like a special array spread across computers. So Spark stores the data, and how it was created, it is lineage. So I have explained this lineage concept in a past video. So if data is lost, Spark recomputes it. That is what we call it as lineage. So think of class attendance sheets. So each CR keeps attendance of their row. If one CR loses it, you still have lecture hall CCTV. So we will be having some backup, right? That backup will be having through these RDDs. Okay. So you can reconstruct the attendance. If some CR misses the attendance, we can reconstruct it by seeing the evidence of CCTV. So Spark does the same way. So one example I have given here. If we have 10,000 students, okay, let us think of a scenario. Spark divides it among computers, all process their chunks simultaneously. So computer 1, 3000 students, 3000 marks. Computer 2, 3000. Computer 3, 3000. So all computer work at the same time, so processing becomes fast. So each computer handles a partition or handles a partition. Okay. So each computer only correct or only collect the marks of 3000 students, and next computer only 3000, next computer only 4000, such that we can execute them in parallel and even fast. Okay. So key properties of RDDs. So distributed, that is nothing but the main thing comes by RDD distributed. That is nothing but the work is split across the computers, across the nodes. Immutable, once created we cannot change it. That is what the main disadvantage of RDD. If you modify, Spark creates a new RDD. We need to create a new RDD. The initial RDD will be gone if you wanted to do something. So immutability gives safety as well as it is some disadvantage. So Spark stores RDD lineage. So it fault tolerant, that is something but lineage is nothing but we can recover the lost data. So it has some lazy evaluation. Nothing runs until we say count, count, or let us say collect. Until we say them, it won't do, which means it is lazy. Like students work only when exam time comes. Okay. So one more thing is nothing but parallel, which is the main advantage of RDD. So tasks spread across nodes. Not only it is not like one after another. It is parallel. That is what the key properties of RDD. So transformation describe the work, whereas actions actually perform it. So transformation just we say map, filter, flat, reduce by key. So this is something but we just say it. But whereas actions only taken by these commands, count, collect, save as text file. So actions they actually run the plan. That is what actions are there. So RDD two operations are the transformations and actions, whereas transformation is like teacher saying like revise unit 1, revise unit 2. Okay. But action, when you take action on exam day, now you really do it, because tomorrow will be the exam. Now you really do it. That is what about the RDD. That is what about transformation, and that is what about actions. Now when to use this RDD, that is what the main question comes. When data is unstructured, and also you need custom logic, you need full control. Avoid RDD when doing analytics, such as when I want a graph, when I want some graph. So when you are doing analytics, you need to avoid RDDs. Okay, but when data is unstructured, when you need a full control of the data, one full control of the system, you need to use RDD. So RDDs, the main disadvantage is nothing but no schema. That is nothing but there will be no columns and all those things. No automatic optimization. Okay, catalyst optimizer. No catalyst optimizer. The work will be slower compared to data frames dataset, and we need to write more code in this particular RDD. That is what the limitations of RDD. Now moving on to the second type, data frame. So a data frame is like an Excel sheet. We come with having rows and columns, everything. So Spark knows the structure, so it can optimize easily. So data frame uses catalyst optimizer. Okay. So data frame uses catalyst optimizer. So what is catalyst optimizer? So it is nothing but auto improve queries. We need to know, we need not to say all those things, it will automatically do it. So that is nothing but catalyst optimizers. And we'll be having a tungsten engine for data frames in Apache Spark. So tungsten engine. So what is tungsten engine? Memory efficient execution. Do this gives us memory efficient execution. So data frames are much faster than RDDs. So they also support SQL. Okay, they also support SQL, Python, Scala, Java, R. So everything is supported in data frame. So like attendance table. So we'll be having roll number one column, name one column, who are present one column. So roll number, Spark understand roll number is nothing but it will be a number. But whereas name text. So it runs smarter. So by using these optimizers, catalyst optimizer and tungsten engine, it will be very faster compared to RDDs. Okay. So I have given an example here. If you look into the example, so Spark knows structure, ID, that will be nothing but numbers. It knows the data type, name, even that is nothing but it knows the type of that name. And marks, again it comes integer type. Okay, so Spark now understands the structure and the data types, which makes the work very easy and which makes the analysis very easy. That is what we need to think about data frames. Now why data frames are faster? So already I said it supports schema, which means columns and rows will be there, which is structured. We can even a common man can analyze it easy. But whereas these data frames uses tungsten as well as catalyst optimizer, which makes the work very easy. Okay, so Spark optimizes automatically. That is nothing but we'll be using catalyst optimizer, and make faster by using tungsten optimizer, and support SQL programming APIs. That is what I mentioned in the earlier slide. So which it supports every language, which means anyone can do. If someone is familiar with Java, if someone is familiar with Python, can do these data frames in Apache Spark. So most real world of Spark applications use data frames. Okay, because it is very easy to use, and even more people can access it, because many languages are there to access it. Okay, now I have given one example. If you look at the example, so some example, if I want to filter marks below 80 or above 80 or equal to 80, I can simply write a code in Python, which is very easy. Df dot filter, I want to filter the marks. And if you wanted to write in SQL style, who are familiar with SQL, so they can write this particular code such that if the data will be available, the statistics will be available. Okay, so Spark SQL lets you feel like a database admin. Okay, that is what the main advantage of data frame. Now moving on to the third type, what is dataset? So dataset is nothing but dataset will be like data frame plus type safety. So type safety but like it is only in Java and Scala. It won't supported by, it is not supported by all the languages that I have mentioned in Dataframe. So type safety is nothing but errors caught at compile time, reduce runtime caches. So which means it do all those things earlier. So as you are executing, some error comes, so it automatically detects that error and it reduces the error cost. Okay. And Python, like let us say Python students don't use dataset because it is only supported by Scala and Java. That is what the thing you need to remember. So I given a comparison here. So structured, when the word structured comes from, when I say Apache Spark, when the word comes about structure, you need to only give two types, because structured will be only for data frames and data sets, no RDDs, because RDDs will be completely unstructured and manual type. Type safe, so type safe only comes for data set, and also RDDs are also very safe, old but safe. One there is one quote, right? Old is gold. So RD, even still Apache Spark has evolved much from RDDs to datasets. Still, the companies haven't removed these RDDs. Okay, that is why RDDs are also type safe, and the speed compared to all those data frame and data sets, the speed of RDD will be low, and which will be very easy to use data frame because it is very structured. But whereas data set is also very easy to use, but it is only supported by two languages, Java and Scala. And SQL support will be only for two types, because data frame and data sets. That is, SQL is nothing but structured, which is having rows and columns. And Python is only supported in two things, RDDs and data frames, no support for data sets. So I have given a simple analogy here. So if you look here, RDD is like a rough notebook, whereas data frame is like neat Excel sheet with columns, and data set is nothing but Excel sheet with grammar checker. If you spell something, if you spell some wrong, for example, instead of say writing Raju, I typed Ramu, I typed Raju. So this type error will be corrected in data sets. Okay. When we should use each? So this is the main question comes. So use RDD when data is unstructured. You need complete control. Won't, because RDDs won't work fast. You will be able to analyze what is doing in the next step, what is going to happen in the next step. So if you want that control, use RDD. If you want statistics or data analytics, you need to use data frames, which is nothing but it supports SQL. Okay. If you want a data set without type error, you need to use data set. You want results without type error, we need to use data set, but no control compared to RDDs. Now I given some definitions that is already mentioned. So RDD is nothing but a fault tolerant distributed collection of data processed in parallel, a distributed table with names and columns optimized for fast processing. It is a type safe but object oriented version of data frame, and which was only supported by Java and Scala. So this is what about RDDs, data frames and data sets. If you are having any doubt, let me know in the comment section. Thank you guys.